Learning Python can sometimes be difficult. You can spend time reading a textbook or watching videos, but then struggle to actually put what you have learned into practice. So, how can you increase your chances of success? By creating projects, isn't it? This is because when you create projects, you get a 360-degree knowledge of both the language as well as the workflow. Therefore, if you're looking forward to master Python with a 360-degree learning curve, here is Junaid from Edureka with an interesting new session on Python projects. So, without any delay, let's take a look at today's agenda. We'll start this session by first having a brief look at Python programming language. Then we shall see various projects like Calculator, Flappy Bird, Turtle Race, Tic Tac Toe application, and voice to text. Before we begin, consider subscribing to our channel and hit the bell icon to stay updated on trending technologies. And also, if you're looking for an online training certification in Python, check out the link given in the description box below. So to start off, let's have a brief look at what is Python. Well, Python is a general purpose high level dynamic programming language which supports object oriented approach to develop applications. Now you might be wondering, what does general purpose mean, right? Well, this means that with Python, we can develop applications for various purposes like web development, machine learning, networking, etc. And also with object oriented approach, everything is treated as an object, thereby enhancing reusability of code, code readability, and data hiding, etc. Now that we know what is Python, let us now see what are the various types of projects that we can develop using Python under 15 minutes. So our first application that we will develop is a calculator application. Here I'll be making use of a built-in Python GUI library that is called as tkinter. So let's move to our code editor and see how we can implement this. Okay, so before you work on any project, right, you have to consider one thing. Before writing even the code, whatever it is, you have to imagine what your outline should look like. So if you think of a calculator, right, first off, it would be like we'll have a display over here, which is usually responsible to take the input, or it's basically like a information that is sent to the end user, right? And then we'll have couple of buttons. So the buttons will be divided here. There'll be couple set of buttons which has only numbers, and the buttons over here which has functions, right? So this is precisely what we are doing. As I'm using this tkinter over here, what this will do is this will allow me to use couple of widgets and layouts. Okay, so let's see how we can implement all of those in our projects. Okay, so first off, what I'm going to do here is like obviously import our tkinter class, and then we'll create a root widget, right? So in order to create a root widget or the main widget, we'll create an object of a tk class, and whatever layouts or whatever widgets that we are going to create, it's going to go inside this root window. Okay, so this is what we are doing here. This part over here is responsible for creating this text input area. Usually the text input area is responsible for providing a textual input to the machine. So here what I'm going to do is using this text input, right, we can also display output to the end user. So that's the reason why I'm using text input over here. All right. And then these are nothing but the callback functions. These functions get triggered only when a button is clicked over here. As you can see here, we have like two sets of button, right? So the buttons from 0 to 9 is responsible for taking the number. And then we have buttons for our functionality, that is for adding, clearing the memory, and also to perform the compute. And all of these functions should be enclosed within our main loop. So let's try to run this application and see how this would look like. So as you can see here, right, this is our main root window. So within this window, we have added various types of widgets. Okay, so each of these widgets are linked to callback functions. And every time we click on these buttons, this callback function gets triggered and we get a desired output. So let's perform a compute, something like we want to perform 9 plus 1. So we have to get the answer as 10, right? So let's see if we can achieve here. So first off, we'll click 9 and then I'll hit plus and then 1. So the answer over here should show is 10. So as you can see here that we have successfully got the answer that is 10. So the next application that we are going to work on is the Flappy Bird game. So here the framework or the library that we are going to use from Python is called as Pygames. So as we all know, Pygame is one of the most commonly used and one of the most popular Python framework to develop games, right? This is because, we can create rapid prototyping. So let's see how we can implement this Flappy Bird game in our application. So let me quickly move to my code editor here. All right, so this is basically the code for Pygame. It's hardly like 122 lines. Okay, so as I mentioned earlier, before we start into like discussing about the code, let's see how our application should look like. First off, we should have a window, right? This window is responsible for displaying our game units. Okay. And then apart from that, if you have played Flappy Bird game in past, you will see there's a bird. Okay. And then there would be a couple of obstacles. So it's usually pipes. Okay. And there would be a background. And there would also be a pavement kind of stuff here. And now what happens is if the bird coincides with this pipe over here, then obviously the game would end. And similarly, if the bird goes too low or too high, same like colliding with the pipe, the game ends, right? So let's see how we can implement this step by step. So first off, we'll create our application window. After once we have created our application window, we'll add some background, and then we'll also add our pavement. Keep in mind this background and pavement, birds and pipe, they're all nothing but images. And we'll manipulate these images by repeatedly creating them again and again. Thus giving a look as if, the pipe is coming from an infinite source. So let's see how we can implement this in our code. So basically here, in order to run, right, we have like, this is the game underscore build method. So this is totally optional. If you want to have a cleaner looking code, you can run this, or it's totally up to you. So I would prefer to have a cleaner looking code. So that's the reason why I'm providing this part. Okay. So let's go to the beginning of this method. So the first thing that I'm going to do here is initialize our Python game package. So to do that, we'll obviously have to import our pygame package here. And then after initializing this, I will create a window. So let me just quickly show you here like how window looks like. So yeah, so I'll create a window whose dimension is 288 and 512 across X and Y axis respectively. And now all the images, like as I mentioned earlier, right? All the components over here are nothing but images. So I'll add a background image and the base image. Like I'm basically loading the image to our Pygame engine, but just by defining or loading our image, right? It will not add to this window. In order to do that, we'll use Blit, which we'll see later in the code. But as of now, as you can see here, we are loading our background image. Then obviously, as I was mentioning about the pavement, right? So over here, we'll have the pavement image, and then we need a bird. See, the bird and pipe are a special case. With bird, we just don't want to have bird which is moving through, right? We also want to detect. So image themselves will not be able to detect whether there's a collision or not. So we use something called as rectangle. So basically how this rectangle works is like, consider that you have a bird. Okay, so let this rectangle be a bird. Okay, so this bird alone, like if there is a pipe here and they collide, we won't know, no? Like it won't be able to, make a decision whether it has collided or not because they're just images. So in order to overcome this, what we'll do is we'll encapsulate this entire bird with something called as rectangle. And similarly, we'll do it for the pipe. And with the built-in functions of the rectangle, we can actually simulate the collision over here. All right. So let's now move ahead and see how what we can do here in further. Okay, so this is the main loop. So as we all know, main loop is basically infinitely running loop. So which executes as long as our application window is there. And within our main loop, we have an event loop. So event loop is basically responsible to capture the events from the end user. And as you can see here with this Blit, right, we are basically adding our images to our application. So what Blit does is it takes the image and it also takes up the position. So this is what we are doing. Oh, here we are trying to add up all our resources to our application window. Sometimes you will also see that we have a callback function. The reason why we have a callback function is because we just don't want the images to be like still, right? So we want something out of it. So we have a couple of callback function like movement of the base. We have the bird movement, like if the movement passes certain position, obviously it has to come down to its original position. So that's what movement of the bird does. Pipe movement, we randomly want to create multiple pipes. Obviously, like if you want like 1,000 pipes, we obviously can't initialize 1,000 pipes, right? We have to find a way to do it. So that's what we're doing here. And this function over here is basically there to detect collision. Apart from just the visuals and images, we can also add music to our application by using pygame.mixer.init. So let's run our code and see how this would look like. So as you can see here, we have our application window. Okay, so in order to control the bird movement, I have to click on the up key. Okay, and now just see, right, the moment bird crosses a certain threshold, right, you can see here that it says exceeded the upper limit. So if I go down, you'll see that it says lower limit exceeded, right? And if I like collide with the rectangle or the pipe, so you'll see a collision coming up. So as you can see here, it says collision. Although I'm just printing out the output here, you can perform various types of functions by just adding a couple of callback functions. So this is pretty simple. It would hardly take you 15 to 20 minutes to develop this game. Moving on to the next application, that is nothing but the turtle race. You see, turtle is one of the built-in package that comes with Python, and basically turtle package is used to like make kids understand how Python, what are the various functionalities of Python and how they work. So let me quickly walk you through the functionalities and how to work with turtle race. And this application would hardly take you 10 to 15 minutes. So let me quickly jump to my code editor. So as you can see here, this is my code for the turtle race application. Before we understand the code, let me quickly execute this so that you get a brief understanding of what is happening here. So let me run our code. As you can see here, right, the turtle actually moved from the center position to this part and starts to create this grid over here. So it would create grid from 0 to 15 as we have defined here, like range to 15, right? So it'll be 0 to 14 over here. And it will then create couple of turtles, right? So it would create 4 turtles. And now the values, like there would be a random values or numbers that would be generated, and whichever number is highest, that number wins. So this is how we can visualize this code. So let us now see how we can implement this using a program. So first off, obviously we have to call off the turtle. Okay, and now we can see here something called as pen up and go to minus 140. Well, as I've mentioned earlier, if this is the window, right? So turtle, the position of it is initially 0. And now if I want to go to this position, turtle will actually move here to this defined position. It would be minus 140 comma 140. But if I don't give this pen up, right, it will drag a line just like this. And then it will start to create the grid. We don't want that, right? So that's the reason why I use pen up here. So with pen up, it will not be drawing a line. Okay, so let's now move ahead. This for loop over here is basically used to create a grid. As you can see, the grid, there were 15 grids ranging from 0 to 14, right? And within the grid, there were like 4 multiple dots. Okay, just to give the ambience of a racetrack. Okay, so this is what we are trying to achieve from this for loop here. Then as you can see, right, there were 4 different turtles which are getting ready to the racetrack. For that, we'll initialize the turtles. And then just to differentiate among all the 4 turtles, we'll give a couple of features. So with turtle, we can give shapes such as turtle, arrow, green, and original. We can also provide color to our turtle. So here I've given like pink, blue, green, orange, so on and so forth. Okay, so this is where we have defined our turtles. And now after that, we have given a couple of features to differentiate each of those turtle. And then we obviously want the turtle to move to this position, right? To this position is the starting of the racetrack. So that's why we have used like from center, pen up, go to this position, and then pen down. We want our turtle like just to give an effect of like, 3-dimension effect. As you can see, right, each of the turtles were rotating. So this is what this turtle do. Okay, so we do the same thing for all the 4 turtles. And finally, we have to move our turtle like really fast. So that is done by this for loop over here. So we randomly initialize a value between 1 to 5, and depending upon which value is highest, that's the turtle that move faster. So let me execute this again so that you get the notion of the code on our application. So as you can see, right, the turtle moved from here to here, so it didn't create a line. So that's why we use pen up. And then this for loop over here is responsible for creating this grid. And this inner for loop is responsible for creating this racetrack over here. And now it will initialize 4 turtles. And this turtle moves here and gives a circular motion or rotation. And now the random values get generated, and based on the value which is highest, that's the turtle which moves faster. All right, so this was the turtle application. Moving ahead, let us now understand one of my favorite application, that is nothing but Tic Tac Toe game. In order to implement this Tic Tac Toe game, I would be making use of this Kiwi framework. All right, so let's now quickly move to the code editor and see how I have implemented this. So as you can see here, we have loaded our code for a Kiwi application. It's a pretty lengthy code, and you might be wondering, is it possible to create this application within 15 to 20 minutes, right? Well, the answer for this is simply yes. Although code is pretty lengthy, but we are trying to just repeat the same functions, okay? So these are nothing but the callback functions which are assigned for individual buttons. So before we understand this code, let me just quickly brief you up with what we are trying to do here. So we all know what is a Tic Tac Toe game, right? So it is one of our favorite pastime game in our classroom. So it's basically like X and zero, and anyone who gets three zeros or three X's in a particular row or a particular pattern wins this game. So just to make this interesting, what I'm doing here is first off we'll have first page. Okay. So in this first page, the end user has to give the name. Okay, and just to keep the game fair, right, like who has to start first, we'll have a toss feature here, and this would randomly initialize the value as these two values will be stored in a list. Okay, and whatever values we get over here would be shown in a pop-up window, and once we hit on this pop-up window, there will be another screen where the person who has won the toss will have an option to choose which option he would like to take. He would either like to play with X or 0, and then he'll have a button here to confirm his selection, and then they would play the game here. Okay, and whichever pattern is satisfied in the background, right, we get a winner of that game by on a pop-up, right? So let's quickly execute this and see how it would look like. Okay, so you can give here player name, so let's give a player name as X for time being, and then player 2 name will give it as Y, and then there would be a toss, and you can see Y has won the toss. So it's pretty fair, right? So now Y provides the input. He can either give X or 0, so let's take X, and then the first option obviously it will be X, 0, X, and then 0. And now if I press X here, you will see X is the winner. So let us now see how we can implement this. So the first off, as I mentioned earlier, this is optional, but it is always recommended to start your code like this. So to run our application, right, we have to call the run method, which is present in the object of my root app. Okay, so my root app is something which has to inherit from the app class, and we're supposed to import this app class, and this will have a build method over here. So this build method is something which is very crucial, and we can have only one build method. So build method is responsible for creating the actual application window. So here, as I mentioned earlier, right, so here I'll be making use of two windows. So I've given the name like each of the window as a class, so it will be like second window, and then there would obviously be a first window. So as this is Kiwi, right? Kiwi provides a KV language. So what is this KV language? Well, with KV language, we can write code in the form of HTML fashion. So as you can see here, right? So we have this player one column and player two, and this is basically like what kind of input it takes. So here we are going to make use of grid layout. So as you all know, grid layout is something which arranges the widgets in the rows and column fashion. So this is what is KV language. So this second window is something, just to give you a better analogy, although I could have used KV language, which would have made my life pretty simple. Just to give a brief understanding, I have used this method wherein I'm defining all my buttons and widgets within this class. So obviously it's a grid class here. So all my buttons and all my widgets would be present here. And each of these buttons, as you can see, is binded to a callback function, which on pressed will activate that particular function. So let's take an example of button B2. So as you can see here, we have given the font size, that is nothing but size of the button. And what text we want is also defined in our callback function. So let's see where we have binded our callback function. As you all know, like over here, we are supposed to pass function call. Okay, self dot button two. So let's go to our callback function. Okay, so this is the callback function for the button two. Obviously, the button, right, has to print either X or 0. So if the previous value was X, then it would be 0. If the previous value was 0, it would be X. So this is why we're trying to have this if condition here. This if else statement or the block over here is used to change or the manipulate the value of our list, which has X and 0 values. And then this describe method over here, like self.b2.describe, this is something which is used to change the value of our button over there. So this is how we define callback function for each of the buttons. As we are using like multiple screens, Kiwi has something called as screen manager. So this screen manager is something which is responsible for handling multiple screens. Although we have something called as page layout, but with page layout, we're stacking one page over the other. We are not having multiple windows. So this is how we can implement tic-tac-toe application using KV language. So moving ahead to our next application, that is nothing but voice to text. I'm pretty sure this would be something pretty interesting to everyone. So if you're someone who is looking forward to make or build projects on machine learning, deep learning, which has natural language processing, right? So this is something which paves you the way, right? So this is the fundamental path over here. So let's quickly move to our code editor and see how I have implemented this. All right, guys. So this is the code for our speech recognition application. So here, as the name says, right, we have to guess the number randomly and speak it out. So before we go to the speaking part, we obviously have to create a list wherein we'll have our words. So over here we have a couple of words. So here like shark, tiger, lion, cat, etc. So now we're supposed to pass this to a random function. And the reason why I'm passing this over here is because I want to choose one value over here. So how random function works is, we give a limit. That's the lower limit is 0 and the length is ls, right? So here it's going to be like length minus 1. Okay. So this is how random function works, and it returns the index. So if it returns 0, it's going to be shark. If it's written like 3, it's going to be cat. All right. So let us now move ahead and see what we are doing here. So first off, we want the word, right? Whichever I have spoken out. To get that word, we use this voice function and we'll pass this list. Although it's not necessary to pass the list, but we're just passing it just so that, I can provide the names. Like obviously have to give a clue to the end user, what are the list of names you gotta say it out. But coming to the speech recognition part, first off, we are supposed to create an object for the speech recognition. So to do that, we'll use something called as sr.speechrecognizer. Okay. And then we'll have this with block over here. Okay. As there will be a lot of ambience noise, in order to remove that, we'll have this particular method over here, r.adjust for ambience noise and the speech. And we obviously have to, like, when we speak, right, there can be any kind of error. So we'll have an exception over here. And if there is any kind of error which is passing out, we'll have it printed in our exception in the form of a string. So what this function would return is the word that we have spoken out. And then we have to validate the words, right? It will choose a random word over here and the word from over here. And if the word, like we are passing the index value, right? So if the word what we have spoken and the word from the index are same, then we'll obviously get the correct answer. Okay. And if not, then it'll just ask us to try again. All right. So let us now execute this code and see how this would work. Okay, so as we didn't speak any word, right? So it just gave it as blank. So what we'll do here is, as soon as I play this and gives me this particular statement here, I'll just speak out a random word and then let's see if our random word matches out with the word that was generated. Cat. So as you can see here, right, what I spoke was cat, but the randomly generated word was tiger. So that's why it's telling me to try again. All right, guys, with this, we come to the end of our session. I hope you enjoyed and learned something new. If you have any questions, please do mention them in the comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!